Hello. We'll talk about some other issues with um, metal solidification. Okay. This is for this lecture 15. First is about eutectic solidification. Probably in your materials engineering class, you learned that eutectic phase transformation is going from one solid in one liquid into two different solid, quite often of different crystal structure, or even the same crystal structure but very different lattice uh, constant and a very different composition from L to alpha plus beta. And this is a special type of solidification, but it involves large change in composition. And in terms of classification, there's a so-called normal eutectic solidification, and generally it yields lamellar or layered structure and some related structure. This picture shows the microstructure for a aluminum copper eutectic composition, and you see that they are closely spaced, we call lamellar or layered structure. This is due to the diffusion has limited distance, so as a result, in order for the solidification to happen, and in order for one single liquid to change to very different composition, it has to form this layered structure. Okay, at a given temperature. Typically, these types of normal eutectic solidification happens when both solid phases have low entropy of fusion or solidification, which means the entropy change from solid to liquid is at the order of ideal gas constant. Okay? Okay. The example would be both of the components are metals, such as the aluminum, copper, as what we um, give here as an example. In comparison, that would be so-called anomalous eutectic solidification. Anomalous solidification, eutectic solidification, it happens when one of the solid phase has high entropy of fusion, which typically means it's a non-metal, such as silicon or germanium. Here we show a micrograph for the structure of a eutectic, but between aluminum and silicon. In this case, aluminum is the metal phase. It has a low entropy of fusion, while silicon is the non-metallic phase that has the high entropy of fusion, which means for silicon, there's a large entropy change during the crystallization process from liquid. And in this case, it's forming various morphology. In some location, as we see here, we have the closely spaced lamellar structure. But in some other region, it's like a dots or even large area with irregular shaped crystals. So that's why we say various morphologies. And this example would be aluminum silicon as what we illustrated here. Okay, this is for eutectic solidification, going from one uniform liquid to two solid with very different lattice parameter and composition, and sometimes also very different crystal structure.